Okay, here we have systems of equations that it's going to be used to solve for a pulley system here. We're assuming that the string is very light and the pulley has no moment of inertia and no friction about it. So we have a pan pulling down. It looks like some kind of a honey pot here across a table. So looking at the forces, straight down here is force gravity. And then we have upward force, the force tension in the cable. And it looks to me like it'll pull in this direction, so we'll make that direction the positive direction. So the net force on this is going to be equal to force gravity minus force tension. Over here we have force tension pulling in this direction here. And backwards is force friction. And of course downwards is force gravity. And upwards is force normal. And we know that those two cross off on a horizontal surface. So our net force equation, force net, is going to equal force tension minus force of friction. So our job now is just to plug in numbers for this. We have a 4.4 kilogram here. So we'll say 4.4 times A equals 4.4 times 9.8 minus force tension. Over here we have, let's see, 1.1 A equals force tension minus 1.1 times 9.8, and of course multiplied by 0.13, okay, which is the mu value. Now we've got two equations and two unknowns, so we need to use the systems of equations. I like to use the addition method with this, so 1.1A is equal to force tension minus 1.1 times 9.8 multiplied by 0.13, and we'll bring the other equation lower. So 4.4A is equal to a minus force tension, okay, plus a 4.4 times 9.8. Now we add these equations together here. Okay, I'm going to drop this down. This would then be 5.5A, and those two will cross off there. So then I have a 4.4 times 9.8, and then minus a 1.1 times 9.8 times 0.13. And of course, grouping like terms together and doing some algebra, the acceleration is going to come out to be 7.6 meters per second squared. Okay, that's giving us acceleration. Now we need to put this back into any one of the two equations. We'll put A in there and then solve for force tension. So let's put into this equation here. So that would then be 4.4 times 7.6 equals 4.4 times 9.8 minus force tension. And solving for force tension, we get 9.7 newtons. And that's how we handle a pulley system, systems of equations.